Ever looked at a jet engine and thought, yeah, that's basically a giant metal tube? Well, that giant tube can launch a 400-ton aircraft across the Atlantic at nearly 600 miles per hour. And the craziest part? The air inside gets hotter than the metal should physically survive. So how does a jet engine avoid melting itself into a very expensive fireball? Let's find out in 3 minutes. At its core, a jet engine does something surprisingly simple. It sucks air in the front and blasts it out the back. That backward blast creates forward thrust. Engineers often describe the process with 4 words: suck, squeeze, bang, blow. Simple enough. But the engineering behind it is absolutely wild. First, air enters the compressor. Rows of spinning blades squeeze that air into smaller and smaller spaces. By the end, the pressure is about 50 times higher than normal atmospheric pressure, and the temperature around 600 degrees Celsius. Then the air enters the combustor. Fuel is sprayed in, ignition happens. Boom. The combustion chamber releases gas heated to roughly 1,500 degrees Celsius. That's hotter than lava and hot enough to melt most metals. Yeah, things are getting spicy. That superheated gas rushes into the turbine at the back. The turbine spins at up to 12,500 revolutions per minute. Think of it like a giant windmill powered by an explosion. The turbine is connected by a shaft to the compressor and the giant fan at the front. So part of the engine's power is actually used to keep the engine running itself. Pretty clever, right? Here's something most people don't know. The fiery core isn't doing most of the work. The giant fan at the front is. In a modern turbofan engine, only about 10% of the air goes through the hot core. The other 90% bypasses it. That bypass air generates over 80% of the total thrust. So the massive fan is basically the MVP of the entire engine. No fan, no flight. Now for the really crazy part. The hot gas inside the engine can be 300 degrees hotter than the metal's melting point. Wait, what? So why doesn't it melt? Engineers use turbine blades made from advanced nickel superalloys. Even crazier, many blades are grown as a single crystal, with no weak grain boundaries. Then they pump cooler air through tiny internal channels inside the blade. Thousands of microscopic holes create a protective blanket of air around the surface. And finally, a ceramic coating acts like thermal armor. Without all these tricks, the engine would literally cook itself. So the next time you see a jet taking off, remember, it's not just a flying tube with wings. It's a machine that compresses air, creates controlled explosions, survives temperatures beyond its own melting point, and somehow does it all safely every single day. Honestly, that's pretty nuts. Subscribe for more engineering explained in minutes.